All right, so we're back to the good old days of factoring quadratics here. I've got another quadratic in sine, but this one the leading coefficient's not a 1. So I just wanted to give you a little refresher on how we used to factor those. So I've got three terms here, two of which, I've got a sine squared and a sine. So I'm going to try to solve it by factoring. Now these first two, they have to be a 3 sine and a sine. Okay, that's the only possible way to get a 3 sine squared. Now for these two, it could either be a 1 and a 4 or a 2 and a 2, or maybe a 4 and a 1, because these numbers have to multiply to give you 4, and then at the end of the day, after you've multiplied everything out, it's got to give you this 4 in the middle. So if I try like a 1 and a 4, this is going to give me a 12 on the outside and a 1 on the inside, which will not give me a 4. Okay, the combination that works here is the 2 and the 2. You see it gives me a 6 on the outside and a 2 on the inside. And with a 6 and a 2, you can get a 4. Okay. The 6 is going to have to be positive and the 2 negative because I want a positive 4 in the middle. Okay, so I'm going to set this factor equal to 0, 3 sine of x minus 2. And I'm going to set this factor equal to 0, sine x plus 2. All right, and this is the reason that this problem is a little bit different. All right, we're going to wind up with an extraneous solution here. When we move this 2 over to the other side, all right, this is not solvable because remember sine of x, just regular sine of x, is always between -1 and 1. So this half right here has no solution. So we can ignore that part of it. We really just have to solve this one. We're going to end up solving sine of x is equal to positive 2/3. Add 2, divide by 3. All right, we need to get our base answers here. X equals, so this one, we're going to have to use inverse sine because it's not a special value. Inverse sine of 2/3. That's our first answer, 41.8 plus or minus 360n. So that is in quadrant 1. 41.8 is about right there. Ooh, turn off my phone. We also want the other place where sine is equal to 2/3. And that's going to happen in the second quadrant at whatever angle this is. All right, so to figure this out, if this is 41 degrees, we want this to be 41 as well. So I'm going to do 180 minus this 41.8. Okay. 180 minus 41.8. And I get 138.2. Okay. And that will represent my answers. Now, go ahead, check your answers, take these values and plug them into the original equation. Make sure you get 0. Or you could graph this thing on your calculator and visually look for where it's equal to 0. All right, let's do one more. This one is going to be, looks kind of harmless at first, but the reason that this one's a little different is because it involves a reciprocal trig function. So cotangent and tangent are reciprocals. So what I'm going to do here is I'm going to multiply the equation by tangent so that it cancels out this reciprocal trig function here and just leaves me with one tangent equation. Okay. So if I take this whole equation and multiply it by tangent of x, all right, the idea is that tangent times cotangent equals 1, and that's because they are reciprocals. So I'm going to be left with 1 equals 3 tan squared. Okay, that's the main trick on this one. That's what makes this one a little different. Let's go ahead and solve this thing. All right, I'm going to move my 3 over. I get 1/3 is equal to tan squared. I can take the square root of both sides. Okay, take the square root, and that's going to isolate my trig expression. So I'm going to get tangent of x is equal to plus or minus the square root of this, which is 1 over the square root of 3. You get the square root of 1 up top, square root of 3 in the bottom. All right, if you want to rationalize the denominator, you can, but I don't need to. And this is one of our special trig values. Yay! So we don't have to use the inverse button on our calculator. All right, this one, I guess you'd break it up into 2 cases, right? Tangent is equal to positive 1 over root 3, and tangent is equal to negative 1 over root 3. X equals, X equals. This is going to happen at all of your 30-degree markers. All right, those are the places where tangent is equal to 1 over root 3. So it's going to happen at 30 and at 210. Okay, so x equals 30, and you don't have to include the 210 because it's just 180 away. And then it's also going to happen in negatives. It's going to be at this 330-degree marker, and at this, what is that, 150? Yep, that'd be 150 right there. Okay, so we'll just say, I'll go with the 150 because it's smaller. Plus or minus 180. All right, and those are going to be my 2 sets of solutions.